Okay, guys, so today's paper is from the international GCSE level, okay, and it's a physics modular paper, okay. I received many comments about these papers. I even got an email from someone requesting that I go over this. I don't know why this is so important and what the deal with these modular tests is. But okay, here it is. This is called Unit 1, and then it has this code name for WPH1 and then paper 1 PR. I don't know what all these mean. If you do, let me know in the comments. Someone even requested that I solve biology papers, and I told them that I am comfortable with physics and math. I'm pretty sure that if I see and if I go through the biology test, I will eventually be able to figure it out. But I haven't done biology since high school, guys. Okay, I studied physics and math, so I don't want to step out of my expertise. Let's say I don't want to say comfort zone. I want to say expertise. Okay, because I'm very comfortable with physics and math. So with all this being said, I think it's let's dive in. But before we do, the thing I always say, this is some general exam strategy, is that, for example, this test takes an hour and 40 minutes, okay? So 100 minutes, right? Oops. So you have 100 minutes to solve it, okay? And if we go to the back of the paper, oops, okay, let's find it. Let's find the back. Come on, over here. So this paper awards 90 marks, okay? So you have about a minute per mark, okay? So this is what I'm trying to say. So if a question awards 15 marks, you should think that you should in the logistics in your heads about the time and the timing, you should budget. Okay, I found the word. You should budget for spending 15 minutes on a 15-mark problem, 10 minutes on a 10-mark problem, etc. So you don't run out of time and you score all possible points. Okay. And other exam techniques that I always tell my students to follow. If you don't know how to start on working on a problem immediately, because you don't have time here. I mean, this is not a practice. I mean, okay, in practice, okay, you can take your time. But in an actual exam, if you don't know how to start working on a problem, skip it and solve something you already know, and then come back to solve the problem that you didn't know in the end, okay? Once you solve everything you actually know, okay? This is gonna build momentum, confidence, so you will have a better chance of solving a problem that you couldn't solve on the first pass, okay? And also make sure you read all the formula, because sometimes you can find the answer just by inspecting what's available for you. And for the GCSE, for some reason, they have formulas in the beginning of the test and in the back of the paper. So let's go find it. So over here, they have formulas for forces and motion, electricity, waves, and all this stuff. So yeah, let's start with problem 1. I have to go back. Where is it? Over here. Okay. First question. And okay, the diagram shows a truck traveling along a horizontal road, and we see that there is a driving force of 16,000 newtons, which is 1 kilonewton is 1,000 newtons, and a resistive force of 16,000 newtons. Question A, the diagram shows the horizontal forces acting on the truck. Give the resultant horizontal force acting on the truck. So we have a positive force forward to the right and a negative force backwards, right? So we have to sum them up. So we have sigma F, the total of all forces, is 16 minus 16, so 0, right? So no force, so 0 kilonewtons. Question B, the driver of the truck has to stop because a tree has fallen on the road. The thinking distance of the driver is 7 meters. The braking distance of the truck is 20 meters. calculate the stopping distance of the truck. You just sum them up, right? I mean, here is the branch, so it takes the driver sometimes to think, so this is the thinking distance. So, and then another 20 meters, so 7 meters to think and 20 meters to stop, so 27 meters is the answer. Okay, easy peasy. Give two factors that would affect the braking distance of the truck. Okay, you can write speed, right? The speed of the truck. If it travels faster, it's going to take longer to stop. The braking distance will increase. The mass of the truck, the heavier, the worse, I guess. And okay, they ask for two reasons. You can write the third one. The tire condition. Actually, I'm going to write a few more, and I'm going to put them in parentheses because you only need two, right? So the tire condition, the brakes condition, meaning that they might be worn, right? So it's going to take longer to stop if the brakes are not new. The road condition. Okay, this. Don't write alcohol, dizziness, sleepiness, not this kind of thing. Okay, so let's move on. Part 3. Which of these factors would decrease the driver's thinking distance? So the road is dry rather than wet. This is not going to affect the thinking distance, right? I mean, why? Then option B, the truck has old worn tires rather than new tires. It's going to affect the braking distance, not the thinking distance. Same with A, pretty much. Part C, the driver is tired. Okay. Kind of affects, but not the right answer. But let's try D. The truck is traveling at a lower speed. Okay, this is going to affect the thinking distance because while you think it's going to travel a much less, a smaller distance, right? So D is the correct answer. Okay, and now part C, also multiple choice. The graph shows how the velocity of the truck varies as it stops. So you have a velocity time graph, and recall that if we multiply velocity by time, which is the area under the curve, we have velocity has units of meters per second, and time has units of seconds. So this delete, and you are left with meters. So the area under the curve gives you a distance. Okay, so keep that thought. Let's read the options. Which of the letters on the graph represents the braking distance? Okay, so this is the thinking. Okay, let's read everything that is wrong. So C is the thinking time, D is the braking time, A is the thinking distance. So B is the answer we need. Okay, I hope this makes sense. I went over it fast. So the correct answer is B. Okay, because B gives you the braking distance. Okay, this was question 1. It awards 6 marks, and you see that it went fast because it was kind of a simple problem, I think. But let me know what you think in the comments. And let's move on to the next question. Okay, question 2. This question is about electrical circuits. The table shows the circuit symbols for some electrical components. Complete the table by placing ticks to show whether each component can visibly indicate the presence of a current in a circuit. So the first one is a light dependent resistor or a variable resistor, right? So no. Okay. The second one is an LED, so yes. The third one is a bulb, so yes again. Then the voltmeter doesn't really indicate the passage of current. The fifth one is a thermistor, so no. And the final one is an ammeter, and it does show you that the current passes through it. So we place a tick there, and we are done. So let's move on to the next question. Diagram 1 shows an electrical circuit containing a cell and component X. The graph shows how the resistance of component X varies with with temperature, give the name of component X. So this is a negative temperature thermistor, okay? So negative temperature thermistor. And it has an acronym. Is it an NTC? I don't remember. But anyway, why is that? Because as the temperature increases, the resistance decreases. And why is that? Thermistors are made of semiconducting materials. So as you increase the temperature of these materials, there are more electrons that populate what is called the valence band of this material. So there are more electrons available in the component. So it becomes a better conductor of electricity. Therefore, the resistance drops. And you can see it from the graph, okay? I'm not sure whether you actually learned this at this level, but I mean, that's the answer. So let's move on. Part 2, using the graph, determine the resistance of component X when its temperature is 50 degrees Celsius. Okay, so let's go back to in the graph. So 50 degrees is over here, right? And we see that the corresponding resistance is, over there you have the 50. So each little square is a 10, is an increase in 10 ohms. So 80 ohms is the answer, okay? So let's go write it down, 80 ohms. The cell in diagram 1 has a voltage of 9 volts. Calculate the current in component X when its temperature is 50 degrees Celsius. Use the formula voltage is current times resistance. Okay, so current is voltage over resistance. So 9 volts over 80 ohms yields 0.11 amps, or we can write 0.1 amps, okay? And we're left with part 4. The circuit in diagram 1 is modified by adding a second identical component X in series with the other components. The temperatures of the first component X and the second component X are reduced to 26 degrees Celsius. Explain how the resistance of the circuit is affected by these changes. So the total resistance is going to be 2 times the resistance of component X because they are in series. So we add the resistances up. Now Rx at T equals to 26 degrees Celsius is, we have to go back to the graph. So 26, okay, each of the small boxes over there represents an increment of 2 in the temperature, okay? So 26 is going to be 22, 24, 26. So this one over here, okay, which corresponds to 160 ohms, okay? 160. You can check for yourselves. So 160 ohms. So the total resistance is going to be 320 ohms. So this R total is 4 times the original resistance, okay? So in other words, resistance is going to increase, okay? And that's the answer. And we are ready to move on to the next question. Okay, question 3. Diagram 1 shows a ruler placed on 2 supports, okay? A bottle is placed on the ruler in the position shown. Question A, Each support applies an upward force on the ruler. The bottle is moved along the ruler towards position 2. Which of these describes the changes to the forces applied by the supports as the bottle is moved? Okay, so as the bottle moves closer to position number 2, okay, the force needed by the force from position 2 is going to increase. Why is that? Because if I put the bottle over here, all the mass of the bottle will be concentrated pretty much on top of this support, right? So it will need to increase the force. Whereas if it's over here, a very small portion of the weight goes on this support. So the answer is C. Okay. So as we move it closer to position 2, the force at position 2 increases and the force at position 1 decreases. Okay. If this doesn't make sense, ask me in the comments and I will provide further explanations. Part B. The total weight of the ruler and the bottle is 7.2 newtons. The bottle is moved until the final force at position 1 is 4.7 newtons. Calculate the force at position 2. Okay, so F1 plus F2 pretty much has to be equal to the weight. Okay, so they give us the force at position 1, so 4.7 plus F2 is equal to 7.2. So F2 is simply 2.5 newtons. Okay, so that's the answer. So we can write it down, 2.5. All right. Part C, draw an arrow on diagram 2 that represents the ruler's weight. Assume the ruler is uniform. Okay, so the center of the mass of this thing is going to be in the middle because it's uniform, right? So the weight is going to be in the middle and it's going to point down. So that's the weight, okay? And you have to specify, I guess, that these lengths are equal, or you can write something like this. Anyway, part 2, the ruler has a mass of 120 grams. Calculate the weight, and the units are newtons, as you see. So the weight is going to be, so 120 grams is 0.12 kilograms. So 0.12 times 10. I'm using 10 and not 9.81 because this is what the specification says. So if we go to the front of the paper, it says when necessary, assume the acceleration of free fall is 10 meters per second square. So this is what I'm using. So let's go back. So 0.12 times 10 is, is 1.2 newtons. This was question 3, okay? I hope it makes sense. Again, if anything doesn't make sense, ask me in the comments, I always reply. Let's move on. And also, guys, don't forget to subscribe. Most of the people who watch these videos, about 85%, are not subscribed. So, yeah. Okay, question 4. A builder drops a bag of waste through a tube to a bin on the road, and we see the diagram, okay? The photograph shows the tube and the bin. The gravitational potential energy stored of the bag decreases by 4,750 joules. As it falls from the top of the tube to the end of the tube in the bin, the bag has a mass of 55 kilograms. State the formula linking gravitational potential energy, mass, gravitational field strength, and height. Okay, so again, this is a formula you can find in the formulas that they give you actually, okay? So where is it? Here. So literally that's a free mark, guys, okay? So you can go back and write that the gravitational potential energy is mgh, okay? Calculate the vertical height of the tube. So we will directly apply this formula. So 4,750, excuse me, and 50 joules is equal to the mass, which is 55 times 10 times h. And if we solve for h, we find 4,750 over 550, which is 8.63 meters. So you can write 8.6. Okay, that's the answer. Part 3. State the maximum kinetic energy of the bag as it leaves the end of the tube. So all GP converts to kinetic energy, right? So the kinetic energy is simply going to be 4,750 joules. Simple as that. Okay, 4. Calculate the maximum speed of the bag as it leaves the end of the tube. So all this kinetic energy is going to turn, we will use this kinetic energy to find the velocity. So this is equal to 1/2 mv squared. So v is going to be the square root of 2 times 4,750 over 55. So this is 13.14 meters per second. So you can write 13.1 perhaps in the answer sheet. So let's move on. Part B. Explain why the speed of the bag as it leaves the end of the tube will be less than the value calculated. So there will be friction. So friction with the tube transfers energy to heat. So this is going to be the answer. Do not write air resistance because it's a heavy bag inside the tube, so there is no air resistance. So I'm going to write it down. So no air resistance. Okay, so this is the answer. We can move on to the next question. Question 5. A student does an experiment to investigate energy transfer by conduction. The student plans to use the piece of apparatus shown in the photograph. So there are metal bars, temperature sensitive strips, and hot water. Okay, the apparatus has 4 bars made from different metals, not materials. When the apparatus is placed in hot water, energy is transferred from the bottom of the bar to the top of the bar. The temperature sensitive strip on each bar changes color as the temperature of the bar changes. The time taken for the color change to reach the top of the bar can be used to compare how effective each metal is at transferring energy by conduction. Give 3 control variables in the student's investigation. So we can write the length of the bars. Okay. They have to be equal, I guess. The water temperature, depth inside water, where you place these bars, okay? And you can also write the thickness of the bars and the width of the bars. Okay, so these are the control variables. These are variables that you have to keep constant and the same for all bars, okay? So the experiment makes sense. So let's move on to question 2. The student had this equipment: beaker, hot water, stop clock, clamp, and clamp stand. Design a method the student could use to compare the effectiveness of the metals at transferring energy by conduction. You may draw a diagram to help your answer. Okay, so the clamp, I'm not going to draw the diagram because I'm not good at that. So the clamp stand, okay, will support the apparatus. Okay, then place the apparatus in hot water. Okay, and start the stop clock. Okay, the next thing is to record the time needed for color change to reach the top. Okay. Let the bars cool before repeating. Okay. And repeat and find the mean. Okay, so I guess this is the method. So we put the apparatus on the clamp stand. We put it in the hot water and start the stop clock. And we will need to record the time needed for color change to reach the top, and then repeat and find a mean. Okay, let's move on. B, the table shows the results of the student's investigation. So for aluminum, it takes 29 seconds, for brass, 64 seconds, and so on. Plot a bar chart of the student's results. Okay, so the maximum time is 115. So we can say that, okay, this axis is going to be the time in seconds. So that's 0, 20, 40, 60, 80, 100, and the top is going to be 120. Okay, so let's start with aluminum. Let's use yellow for aluminum. I don't know why, no particular reason. So 29 seconds, we see that this is going to be 30. So every little box there is 2. So 20, 22, 24, 26, 28. So we have to go somewhere there. So in the middle between, oops, I'm trying to draw it. It's the idea is that it's between the middle of 2 of the little ticks, if that makes sense. Okay, so that's the aluminum. Next one is brass. Let's use something reddish. So 64. So this is 64 over there. Okay, so this is kind of easier. Okay, so this is brass. Copper 22. Let's use another color. Let's use this. So copper is 22, so it's the smallest, I guess. So that's the 22 seconds up there. Okay, so this is a copper. Okay. By the way, you can make these bars thicker, but okay. And then steel, I'm gonna use blue, 115. So 110, 12, 14. So somewhere there is the steel. Okay. Let's try again. Okay. All right, so this is the bar chart. Took me a while, I'm sorry. So let's move on to the next one. Deduce which metal is the most effective at transferring energy by conduction. This is going to be the metal that takes the less time, so copper. Okay, so copper takes the shortest time. Okay, so it has the fastest. So it has the fastest energy transfer. So the diagram shows a railway engine moving towards some stationary carriages. Okay, and the direction of movement is backwards. Okay, when the engine collides with the carriages, the buffers on the engine push on the buffers on the first carriage. The engine and the carriages then move together in the direction shown by the arrow. State the formula linking mass, velocity, and momentum. So momentum is simply mass times velocity. The engine has a mass of 9 times 10 to the 4 kilograms and moves at a velocity of 0.72 meters per second. Calculate the momentum of the engine before it collides with the carriages. Include a unit in your answer. So this is going to be P equals 9 times 10 to the 4th times 0.72, which yields 64,800 kilograms times meters per second. Okay, so we have the unit and the answer. So let's move on. After they collide, the engine and carriages move off together. The total mass of the carriages is 6 times 10 to the 4 kilograms. Calculate the velocity of the engine and carriages after they collide. So momentum is conserved, right? So we have Pi, the initial momentum is equal to the final momentum, okay? The initial momentum is 64,800, and this is going to be equal to the mass of the system, which is now 6 times 10 to the 4 for the carriage, plus the weight of the engine, right? Which is 9 times 10 to the 4 times the common velocity. So we have that V is going to be 0.43 meters per second, okay? And now question B, the buffers on the engine and carriages have strong springs. These springs compress when the buffers push against each other. Explain how the springs in the buffers make the collision more comfortable for passengers in the carriages. So the springs, okay, increase the collision time. The collision time, okay. Force is the change in momentum with respect to time, right? So we have the same delta P occurs at a longer time, at a longer delta T, pretty much. Okay, so the force on passengers reduces, simply because it takes more time, okay? Because we divide the same change in momentum with a longer interaction time, okay? This was question 6. We're ready to move on to question 7. Okay, question 7. A metal ball is dropped from a height into a pool of water. The graph shows how the velocity of the ball varies with time. Describe the motion of the ball before it enters the water. So the point where it enters the water is over there with red cross. Okay, so we see that it accelerates. I mean, it goes from 0 to 5 meters per second in 0.5 seconds. So it accelerates with a constant rate. Okay, so accelerated motion with constant rate or constant acceleration. How do we know it's constant? Because it's a line, okay? So the gradient of this line gives you the acceleration pretty much, which is gonna be g pretty much. Okay, question 2, using information from the graph, determine the initial height of the ball above the water. Okay, so this is a velocity time graph, so the area under the curve gives us this height, okay? And we have to pretty much find this area, okay? So 1/2 times 5, and this is meters per second, times 0.5 seconds yields 1.25 meters, okay? And that's the height. Part B, explain why the velocity of the ball decreases to a constant value as the ball travels through the water. So let me use a clean page to draw the forces on the ball. So we have the weight, we have the drag, and okay, we have the upthrust as well. I don't know if you learn about this, but in any case, so we can write that weight acts down, drag acts up. So D is larger than the weight, which means that the ball decelerates, initially at least. Okay, now as speed, so as speed decreases, as speed decreases, so what I'm trying to say is that when it enters the water, it experiences a large drag force, so it decelerates, but then as the speed of the ball decreases, the drag decreases. Eventually, drag becomes equal to the weight, right? So acceleration becomes 0. Okay, and ball travels at a constant speed. Okay, and that's the answer. Part C, the pool of water has a depth of 2.85 meters. Calculate the pressure difference between the surface of the water and the bottom of the pool. They give you the density of water. Give your answer to two significant figures. Okay, again, if you go to the formulas they give you, let me see. Is it over here? I don't see it. Here. They literally just give you this, okay? So you just have to apply. So pressure difference is equal to the height times density times G. So let's go back here. And let's write this down. So pressure is rho times G times H. So 1000 times 10 times 2.85 yields 28,500, and the units are pascals. And to give this in two significant figures, we will just write 29,000 pascals. Okay, two significant figures, these two. Okay, this was question 7. We're ready to move on to question number 8. Okay, question 8. A student uses this equipment in an investigation to determine the specific heat capacity of a metal. So we have the solid metal block, the electric heater, and the power supply, okay? The student uses an electric heater to heat the solid metal block. They record the temperature of the metal block at different times as it is heated. Name the piece of equipment used to measure temperature. Okay, thermometer, I guess. Okay, part B. State how energy is transferred from the power supply to the heater. Electrically, I guess, okay. So let's move on to part C. The student uses a device called a joule meter to measure the energy transferred to the heater. Describe a different way the student could find the energy transfer to the heater. Include the measuring devices needed. So they will need, so we can find the energy by multiplying current times voltage times time, pretty much, okay? So for this, they will need, to find all these measurements, they will need an ammeter, a voltmeter, and a stopwatch. Okay, and that's the answer. D. Explain how the student could reduce the thermal energy transfer from the metal block to the surroundings. So they have to wrap it in insulating material, I guess. So wrap in insulating material to reduce heat transfer by conduction or convection. So by conduction or convection to the surrounding. Okay. Finally, part E. The heater transfers 16 kilojoules, which is 16,000 joules of energy to the metal block. The temperature of the metal block increases by 54 degrees Celsius. The metal block has a mass of 0.7 kilograms. Calculate the specific heat capacity of the metal. So energy is C times M times delta theta. So C is energy over mass times delta theta. So 16,000 over 0.7 times 54, and the units are joules, kilograms times degrees Celsius. So this yields 420 joules per kilogram per degree Celsius. All right. Part F, this is a long problem. The student repeats the investigation with a block of the same mass made of a different metal. The power of the heater remains the same. The graph shows how the temperature of each metal block varies with time. Explain which metal has the larger, specific heat capacity. So this is metal B, right? And the reason is because it takes for the same time, right? So if we take that amount of time, you see that the temperature of metal block B is less than the temperature of metal block A, which means it takes more energy to heat up metal B. Okay, so metal B, because it has a shallower gradient, okay, which means it takes longer to heat up. Yeah, just that. It takes longer to heat up for the same amount of energy. Okay, this means it has a higher specific heat capacity. Okay, and this was question 8, a long problem, okay, but I think straightforward. And we are ready to move on to the next question, which is the last one in this paper, okay. Question 9, an incubator can be used to keep things warm. I don't know what an incubator is. If you do, let me know in the comments. To me, it sounds like one of those machines that you put chicken eggs inside and then it incubates them and you have little chickens coming out. But I don't know, let me know in the comments. So the incubator has 2 electric heaters. Diagram 1 shows a model, of the heating circuit made by a student. State what will happen if there is a break in the wire connecting heater 1 to the power supply. So if this breaks pretty much, okay? So it will stop working. So both heaters will turn off. Since They are in series. Okay. Part 2. Diagram 2 shows a wire connected in parallel with heater 1 in the student's circuit. Explain what happens to each heater when the wire is connected in parallel with heater 1. Assume the wire has a low resistance. So pretty much what's going to happen is that the current will not go through heater 1. It will go through the cable instead because it has a lower resistance. Okay. So let's write that down. So current takes the path of lowest resistance. So all current will go through the wire. Okay. Heater 1 will turn off. And then heater 2 gets more current and becomes hotter. Okay. And finally, part B, the student decides to build a different circuit using the two heaters. In this circuit, each heater can be turned on and off separately using switches. Complete the circuit diagram to show how the two heaters and switches could be connected. Okay, so you can connect them like this, I guess. So this is the switch. Oops, I forgot. We also need the heater, so heater 1, okay, and there is a switch, and then we can also do heater 2, okay, and I think this is what they ask. Let me see. Yeah, this will allow you to turn on and off the heaters independently, right? I mean, if I close this switch, heater 1 will be turned on, and then yeah, okay, I think this works. Okay, this was the modular test from May 2025, so last year. Let me know if these videos are useful. Okay, I have to admit that I have a preference for the A-level tests, but okay, I mean, people find these useful as well. So hopefully gradually I will start uploading videos. Maybe I will not make it through this exam season of May and June 2025 because I have many things in mind. But during the summer, I can upload more of these videos and past papers from the GCE level. Please subscribe and let me know what you think in the comments, and see you in the next one. Bye.